This is a full step-by-step tutorial for a MAX7219 FC-16 LED matrix display that can be customized with text using a web console or a smartphone. The display is connected to a NodeMCU ESP8266 Wi-Fi based microcontroller. We will be using Blynk.Cloud and Blynk IoT to manage and control the entire system as well as the text output. For the code, we will be using Arduino IDE 2.0 on macOS, which of course is also available on Windows, and the Parola library. So this is the Fritzing diagram. We have the 32x8 LED dot matrix displays. We've got two running in a series. So what we do is we take both of these and we solder them in the middle. You can also use jump wires to connect them, but we want this to be a more permanent fixture, so we do solder them. More on that later. Down at the bottom, we have the NodeMCU microcontroller. We have connected that to a half breadboard. And on the left-hand side, just to power up the whole thing, we have a breadboard power supply module, which is connected, configured to 5 volt. You have to make sure that both of the jumpers are set to 5 volt. And we are also using a series of jump wires. So just for this tutorial, we're going to use green, yellow, and orange for the clock input, the chipset, and the data. So that's green, yellow, and orange. So again, this is clock, chipset, and data. The labels will be on the back of the matrix display panel. We're also going to power this up, of course, with the red wire and the black wire, and that will be 5 volt rails, which will also be used to power the microcontroller, as you can see right there. And we're going to plug the green, yellow, and orange wire into digital pin 5, 7, and 8, or 5, 8, and 7. So these are all the components that we need. Let's just go through each of them one by one. So first we're going to need two MAX7219 FC-16 32x8 LED dot matrix displays, one half breadboard, and the breadboard power supply module. This is the NodeMCU microcontroller, which has Wi-Fi support. We also need two small male-to-male jump wires. That's for connecting this board to the power. And we'll also need 5. These are 20mm male-to-female jump wires. And this is for connecting the board to the matrix displays. We also have these header pins, and we only need 5 of these actually. So if we just take this and we just snap that off and put that there, we're going to need that to connect this. Well, actually, this is going to connect in the middle, and there's a reason why we have a soldering iron and some solder, because we would like to solder these two together, and these header pins are going to play a vital role in that. So first thing we're going to do is we're going to take these two matrix panels and connect them together in a series. We want this to be a more permanent fixture, so in order for that to happen, we have to use the header pins to connect the two together and use the solder and the soldering iron, in theory, to permanently fix them together. So I'd like to show you one of the panels. If I flip it over, you can see this is where we have to connect the panel to the board. So I've put these aside for now, but we have these jump wires, male to female ones. So if you just take a look, I'll just show you. So to plug in the power, we have the VCC in the ground. We also have the data in. We have the chipset, chip select more like, and the clock pin. So these are all the input pins, and we know that because it's got the in there, and it will flow to every single FC-16 all the way down. And of course, if we're daisy chaining this together in a series, it will just keep going and going until it reaches the end, just like that. Now, if we flip this over again, so what we're going to do is we're going to put these two together. So in order for that to happen, we need to take off one of the FC-16 display, so let's put that aside. Also, for intents and purposes, it is a MAX7219 chipset. So anyway, we're going to take out, now below me, I'm going to take out the other one. So we've got it like that, as you can see. Right, you'll notice that there are some holes to put in some pins. We're going to use the header pins right here. Now, you've got the long bits on the right-hand side and the short bits on the left side. You want the long bits to be sticking down, facing the ground. So what I would do, I'm sure different people have different ways of doing it, but this is how I do it. You know, feel free to come up with your own way. You can use jump wires, but like I say, I want this to be a more permanent fixture, and I want these two panels to be together. I don't want them to be split apart, because we're going to have words, especially in the center. All right, so what we do is we just get that plugged in there. Yes, just like that. And what you would do theoretically, although I have to admit, we're not going to show you how to solder in this video, but what we would do is we would literally solder these parts. You'd solder all the pins so that they remain in place. And then what you'd do is you'd get these two panels, and you have to align them according to the pins. So do not, I don't think you can do it the wrong way round. So anyway, if you align those together, the clock touches the clock, and the VCC touches the VCC, right? You can sort of see, and what we do is we just, if I can just hold it here. So what we would do is we would, theoretically, we'd solder these contact points here. So where it crosses each other, you would put some solder. So there we go, we have just soldered it. We've soldered all of the contact points, all 5 of the contact points. Okay, the front and the back has also been done as well. Now what we need to do is put the FC-16 panels back to where they are supposed to be. So we will do that. Okay, there we go. That's it. We now have a 64:8 LED matrix panel display, and it's a permanent fixture because we have soldered it in the middle. Brilliant. So now let's put this all together. So let's take the NodeMCU controller and let's put that protective styrofoam on the left-hand side, and let's grab the breadboard. So yeah, with this one, this power supply module, you want to make sure that these pins are set to 5 volts, so make sure the jumper is on 5 volt and not 3.3. So you also want to make sure that you put the positive rail, it has to be at the top, it has to align positive to positive, so it has to be there. And how do you know that? Well, if the negative blue rail is towards you, that is the correct way, and the red part is facing up. That's how you know. And we're also going to take the microcontroller and plug it there, so it fits snugly in. So when you push it in, you'll notice that there is a row of pins at the top that you can use, as well as pins at the bottom, so it's a perfect size, actually. So there, we plug that in. Now we want to get this plugged in with the jump wires. So what we do is we simply just take this. So now we're going to get the jump wires connected to the input pins of the matrix display. So let's just grab the VCC and plug that in. So that's red. We're also going to use black for the ground. For data in, we are using orange. So these are male to female, because we're going to plug the other end into the breadboard. The yellow wire is for the chip select, or the CS. And for the clock, the CLK, we're going to use the green wire. Just like that. There we go. So it's all plugged in like that. So what we're going to do here is connect the NodeMCU microcontroller to the power. So in order to get that done, we have to connect the red jump wire to the positive rail at the bottom, which will be powered here by the 5-volt rail. We'll put in a battery, or you can even plug it up to the wall if you so choose. We're also going to use the black jump wire to connect to the ground. So now we have a circuit. So yeah, just get that in there. Right, good. And the last thing to do is just get this matrix display connected to the board. So we need to connect the green wire to digital pin 5. So that's there. We also want orange to be pin 7. Right, that's clock and data input, and this one is the chip select, which is the yellow wire, and we're going to use D8, digital pin 8 for that one. So we plug that in, and of course we want to power this thing, so we want to hook this up to the positive and negative rails. I mean, we could use the one at the top. The Fritzing diagram has that at the bottom, but it really doesn't matter, but we could just plug it in at the top. So yep, just like that, and just like that. So there we go. That's the device. So this is the sketch code. We are using Arduino IDE 2.0.0 as of this video. And for intents and purposes, I will be using Arduino IDE version 2 from here on in. You can download it for free from the arduino.cc. There are Windows, Linux, and Mac OS versions. Of course, I am using the Mac OS version. So what we need to do, once we've downloaded and installed it, here we have IDE. You can download this code from the description section of the YouTube video. We need to make sure that this can connect to the NodeMCU board. So what we do is we go to Arduino IDE, go to Preferences. You want to make sure that the board manager URL for the NodeMCU board is in there, because what happens if you go to the board manager, you can either go to Tools, Board Manager, or you can click on the left-hand side. You can type in ESP8266. Because it's not there, we need to add the URL. So we go to Preferences, and we need to put in the additional URL, which, by the way, and I will put this in the description box, the description section more like, and it's right here. So we need to copy this. This, of course, is also in the description. So we just paste it in there, and let's just stretch that across and press OK, and just search for ESP8266, and there we go. We install that. We're on version 3.0.2, so let's install that. Okay, brilliant. And now we can press that to minimize it. We also have the library manager. We can also go to Sketch, Include Library, Manage Libraries. So when we get to the library manager, which is on the left-hand side here, you will need to search for the Parola library. So that's P-A-R-O-L-A if we want this one. So right now we're on 3.6.1. So install that. It's also going to ask if you want to install the dependency. So that's the MAX7219. That's the one we need. So we're going to install all. We're going to have all the libraries that we need. If you try to verify the code, it may tell you which libraries will be missing, and if that's the case, we can simply just download it from the library manager. No problem. Right, so case in point, if I press the verify button on the top left corner, right, it will tell us, for example, the Blynk Simple ESP8266 is missing, so we need to download that as well. That is for the Blynk library. So if we type in BLYNK, IDE 2.0 actually makes it easier to download all of the libraries. It seems to support a lot of the, like even the non-Arduino stuff, as well as Blynk. It's a lot easier now. And now we've got up to version 1.1.0, and we simply just install it, just like that. And again, you can click that and just press verify, and let's see what happens. Just to make sure that the code is all working and all the libraries and the dependencies and so forth are all working. Let's just see how it goes. I am aware that I have not filled out the Wi-Fi credentials and so on, but that's fine. I'll do that later, and that seems to be it. So let's have a look at this code. Now, the top part where it says define Blynk template ID, device name, and auth token, we need these in order to link up the code with the NodeMCU board to the whole Blynk IoT system. We'll get to that soon once we access Blynk Cloud. We've already sorted out these libraries, so let's keep moving down. So as we know, we are using the MAX7219 matrix display. That's the 32x8, and we have in total we have 8 FC-16 8x8 displays all tied together in a series. Originally this was supposed to be 4, so we've doubled it because we have daisy chained and soldered 2 together. So that is going to use all 8 in the same system. Now down here we are defining the clock pin, the chip select input pin, and the data input pin as well. So clock pin, chip select input, and the data input. All right, and we have color coordinated it as green, orange, and yellow. Down here we have an instance of the Parola. We are using the Parola library to make up all the fonts and the types of animations. And by the way, we will not be doing any scrolling animations for the text. We're just going to have static text that will be smack bang in the middle. More on that later. So we have to specify what kind of hardware. So we're using this hardware, and we specify the chip select input pin, and the number of devices is 8. So we specify all that with the instance P. We have to put in our Wi-Fi credentials in there, and down here we are going to be using virtual pins. So we've got V4, V5, V6, and V7. Looking at the front end display, what's going to happen is we will have 3 terminal windows, and every time we input to those terminal windows, it will store it in a virtual pin, which we can use. We can pass that into the matrix display. And down here we connect to the Blynk Cloud, and at the bottom, oh yeah, we also start the Parola device. And down here, this is what the code that we need to use in order to make the text appear. So this part here where it says p.displayText, what happens is we have programmed the text to appear in the center. So it will always appear in the center. There'll be no kind of special effects. It will just print on the screen smack bang in the middle. And down here, what I've done is I've put some statements here just to help users. So anything that's in value 1, so anything that you put into the first terminal, it will output, that will be the first string that's output on the display. And this part here, so after a period of time, we have this thing called the delay value. So there'll be like a scroller. There'll be a scroller that you can use, and you can specify the amount of time between each string. So for example, you might have hello for 3 seconds, and then it will have another message, and then another message. You could have up to 3 different strings, and they all have an interval of the delay value. Okay. So it will be like this string first, and then it will delay, and then it will be this string, and then it will delay, then it will be this string, and then delay, and then it will just go in a loop, because it's in a loop, right? So that will go. Now you'll also notice we have a V8 as well. That's the this is like a sort of a label. This is a label that's on the web dashboard as well as the phone app, and this will show you what is being output from the matrix panel. So it's just a little extra I thought would be quite nice. But the most important part is this. Okay, we're going to be transferring stuff from input boxes or terminals into the matrix display. Anyway, that's quite a lot of talk, so I think we better get into Blynk IoT and Blynk Cloud. So let's go. So we are now at blynk.cloud, or at least we're just about to get into blynk.cloud. So we'll need to sign in with our email address and password. So once we are in, we're going to create a new template. So on the left side, start a new template. We are going to be using ESP8266. There is actually no NodeMCU per se. We have to use ESP8266, and we're going to call this Matrix Display IoT, or just call it whatever you like, it's fine. And then press done. Now we are going to add some data streams. So by the way, just as a reference point, I'm going to just put the IDE code over there so we can have something to reference. So I'm going to press new data stream, and we're going to create some data streams for the virtual pins, and I'm sure by watching this tutorial you'll understand it a bit better. So we have virtual pin 4, 5, 6, 7, and we also have one for 8. So let's just start. So we're going to create a virtual pin, and this virtual pin will be for a slider to configure and toggle the delay time between each string that's output onto the matrix display. So this will be called delay time, and this will be V4. It's an integer, so that means it's a whole number. And by the way, we are looking at this one right here. So we don't need units, and it will go from 0 all the way to 10. You can set a default value, but I'm not going to. I'm just going to leave it at 0 and then click create, and there we go. So that's how it looks. Right, now let's keep going. So we need another data stream. We want one for the first terminal input, the first input on the web dashboard. And this will be, we're going to call this string 1, and that will be V5. And because it's a string and not just for numbers, it's data type string. You can set a default value, but I'm not going to. And then press create. We also want to create, we could just keep pressing new data stream. What we could do is just duplicate that. So just change that to string 2. Just make sure you use a different, well, you have to use a different pin. It will say which ones are used. So we'll do that. And yep, and then we copy this again. And then this is V7. So yep, that's pretty much it. Oh, sorry, that should be string 3, not string V7. Okay, and there we go. So we've got 3 input strings for the terminal windows. We'll get to that in just a moment once we get to the web dashboard. This is for the delay time. So each time a string is output onto the matrix display, there will be a delay time which is toggled with this. Again, more on that later. We also want to have a label that showcases what's coming out from the matrix display, whether it's on your phone or in this case, the web dashboard. We'll get to the phone bit later. So we go back to new data stream. So before we did V6 and V7, we've done that already. So now we're going to work on this one, this V8. Yeah, there's a few of them. See, one there, and one there. So this one is going to be V8, and oh, we need to scroll down. And this will be a string, okay? And this will be, we'll call it matrix output or something, just anything you like. So that will be that. We'll call it matrix output. Press create, and that's pretty much it for that. Now we need to go to the web dashboard, and for this one we need a slider. Okay, and this is going to be for the delay time. So press this button and yep, use the data stream delay time, and I think that's pretty much it. You can just maybe we'll have delay time, yep, 2 words, and just stretch it out like that. Now, some people have been asking, why can't you use text input rather than having a terminal window? Well, text input you have to upgrade, so we have to pay, and we're not doing that yet. So we're going to stick with the terminal. So terminal works just as well. So we're going to edit this, and this data stream will be string 1. So anything that we put in there will go into string 1. It will go into pin value 1, and the others will be 2 and 3. Okay, so let's do that. Okay, I'm going to use add new line, All right, so that just means anytime I put in a word and press enter, it will go to the next line automatically. You can see the difference like that. Okay, so that's, we're going to call this one, we'll call it string 1. And we're going to duplicate that and have one for string 2 and string 3. Just again, make sure you choose the right data stream. Okay. So just configure that. String 3, which is v7. Okay, we've got that. Now you might want to space it out a bit. So you want to maybe just adjust the size just a little. Okay, you can always go back and change it if you find this doesn't work out too well. All right, we also want to have the output of the matrix here. So you're going to need label. There you go, that's the one. This is what we want. So if we press that, and data stream has to be matrix output. All right, so, just let's space that out a bit. There we go, so that's that. And now we're ready to save this. So we'll press save. Okay, and this is how the interface will look. So we've got all of the 3 terminals for each string. This is what it will be output from the screen, and this will be the delay time, okay, in seconds. And now we go to my device, or go to new device, and we want to create a new device from the template. So matrix display IoT, we'll just keep the same name, and that's it. Now we're going to need this code. We're going to copy that, and since we have the code right here, we're just going to paste the code inside. So this code has to be copied, and we want to put this in there. So let's do that. So we'll just like that. And you also want to make sure that you put in your Wi-Fi credentials. So let's do that right away. So we're almost about ready to upload this code into the NodeMCU board. So I'm just going to maximize this. So just make sure that you get your micro USB wire, plug one end into the computer and the other end into the back of the NodeMCU board. And then once you are done, just make sure that the board is connected. So you want to go to Tools, Port, and then pick the serial port for the board, and of course make sure that you've got the right board. So we are using NodeMCU 1.0 ESP12E module, and press the upload button, top left corner. Right, it has now finished with the upload. Now go to the top right corner, press the serial monitor, make sure you're at 1.15.200 board, and it's now connecting to the your Wi-Fi module. Yep, and yep, there you go. And if you get that, it's already connected to Blynk. So you can see right there, it is connected to Blynk. Now it's time to program the Blynk app using the phone. So we are using an iPhone, and we're going to log in because I've logged out previously, so I need to log in again. So we're going to put in the email address, which we've done already. We're going to put in, whoops, sorry, the password. And you'll see Matrix Display IoT is already there, so just press that, and top right corner, press the wrench tool, and we're going to start building the user interface. Very similar to what we did previously with the web dashboard. So hit the plus button on the top right corner and use the slider. Remember, we can only use the free widgets, so choose wisely. Now we're going to call this delay time in seconds, and the data stream will be delay time. Virtual pin number 4. Now let's do that. Now we're going to also press the plus button we also want the output. So we want the, I believe it's the, is it the value display? Okay, the value display, and the stream will be matrix output. And let's have the text color as red. So just pick the red color, and you can pick any color you want actually. And you can also change the font size if you so choose. I'm just going to keep it at medium, and we'll call this matrix output. Okay, and that's that. You might want to make this slightly bigger so you can see it better. And now down at the bottom, we also want to add the 3 terminals. So find the terminal, so that one. Okay, and just call that string 1. The data stream will be string 1, v5. Okay, and great. Now we want one for string 2 and string 3. So we just do exactly what we did before. And then the data stream will be string 2. Okay, new line, and let's add one for string 3. And the data stream v7. Okay, now I believe that's it. So just press the close button on the top left corner, and that's pretty much it. And then you just press it and just give it a test. Hello, welcome, bye, like that. Right now we're only testing the phone, we're not testing the matrix display. It is online because it doesn't say it's offline on this screen. So we can change the delay time at the top. So 5 seconds, 2 seconds, 1 second. Okay, just like that. Right, that is pretty much it. So we have the matrix panel here, now 64x8 matrix display. We've got the NodeMCU system down here at the bottom. By the way, I think I'd like to try using a 7.4 volt lithium ion battery. So we're going to disconnect this, and we're going to plug this straight into the barrel wire connector down here and just push the switch on the breadboard power supply module, just like that. Okay, now this is turning on, and while we're at it, I'm going to grab the mouse, and inside the Blynk.cloud, we're going to go to Matrix Display, My Devices, Matrix Display IoT. It actually says it's online, so just to make sure this thing is working, this is what we get. Okay, I'm going to actually use my phone here. So now I've got my Android phone with the, before I was using the iPhone, but now I'm using the Android. So watch the panel at the bottom. In fact, I'll put it here. And if I go to there and, oh, hang on, let's, okay, this is what I want. Right, so now if I say delay time of 3 seconds, if I type in hello, H-E-L-L-O, and just wait for that. Yep, there you go, it's right there. See? And now it will go to the next string. So string number 2. I have to apologize, the keyboard's actually covering up the input box. I'll type the word welcome. And down here, I'm going to type, sorry, it's covered up. There we go. Right. You'll notice whatever I type, it automatically pushes to this screen as well. So now it's saying, hello, welcome to this video, just like that. Now, if I grab a keyboard, my desktop keyboard, let's see if this works. Right, you can just make it out. So I've got my keyboard here and I've got my mouse here. I can just toggle with this. So now the delay time is going to be 1 second. So you see now it's a lot quicker, and it automatically pushes to the phone. So it automatically will push the delay time to the phone. So if I make that 10 seconds, it will automatically push on the phone, and vice versa. And it will also show what's on the output as well. So right now it says hello, it says welcome. So now let's give this a try. So if I use my keyboard, I might just, we could just zoom in a bit. So hello, let's put in another type of string. Let's put in, let's put NodeMCU. And this one we'll put string 2, we'll put IoT. Don't forget to push enter. And this one we'll put in nice day. Let's try an exclamation mark, see what happens. There you go, IoT, nice day. Now, does it do apostrophes? Let's see, IT apostrophe S, what am I saying? IT apostrophe S, that's its. Yep, it's got an apostrophe right there, brilliant. It's a good day, exclamation mark. All right, so there we go. It's a good day. It's a lovely system, but there is one snag. It doesn't have the capacity to remember the strings that you put in. So every time you turn it off and turn it on, you've got to manually input the strings in again. So right now there's nothing in there. So let's type this is, oh, that's flashing. Let's make that 2 seconds. This is the end of the video. Okay, just wait for that. This is the end of the video. So there we go, guys. Thank you so much for watching, and we'll see you again soon. Take care, and goodbye. Thank you.